So first of all, when you open Zalando application, you see that some page with some campaigns, some collections, whatever else. But when you start searching for real products, you get into the catalog. Catalog is where you can browse the product, when you can search for products, when you can filter the assortment. And this is like the very basic part of the application. So if catalog is affected, it means that customers can't browse, they can't order in the end, and they won't buy anything. It means that as catalog going down, we get immediately large financial impact to our business. So it treated as a tier 1 service. So it's like the highest criticality for the services we have here. Like catalog, ordering, payment, that's the basic things that if they don't work, it meaning the fashion store doesn't work. Now, what happens if something doesn't work? So it started like a few alerts about delays and increased latency, and obviously it took some time for the team to realize how big how big the problem is. So it's not like the full outage of the catalog; it still continued to work, but for some customers, like for many customers in Germany and also in Italy, it produced delays, and in the end, it makes them to stop ordering and to stop browsing, and even to leave some bad review in the Play Market, like the application telling you to remove filters to search for articles, but I didn't put any filters, and it says me, it doesn't let me. So this is something doesn't work. And this actually, the second outcome of the issues with the catalog. If the customers are disappointed, they may never return. They may just say, it doesn't work for me, and remove the app. So the firefighting. Firefighting is like how we name the process when we're searching for the root cause. We're looking on the monitoring. We're trying to get our understanding about what's going on. We're trying to get some hypothesis about what's happened. And depending on this hypothesis, we try to apply different playbooks. So that's what the catalog team did. They looked at the load was increased, the CPU usage and memory usage was increased, the latency was high, so they decided probably they get an increased load. And they started applying playbook. They started scaling up. They limited the ingestion, I mean, like the intake of the new products into the catalog, and some updates, and doing other things. But it didn't help. So the problem persists, and it was kind of unclear, like what to do, and it take actually a lot of like pretty long time to figure out what's going on. So finally, they found that there are some requests that are slow, and probably this request are the reason why the catalog is slow. And by the way, catalog based on the Elasticsearch. That's very big. Well, currently it's multiple Elasticsearch clusters, but that's not the point. That was the biggest cluster that serves for Germany. And that was an issue with it. They have this slow log that contains the queries that were slow, but at that time, this log doesn't help to figure out where the request coming from. They like assume that it's coming from from the fashion store. So they probably, there are some users who search for some combination of filters, and this combination of filters come to some like complex queries that makes the Elasticsearch working slowly. And eventually, about like 7:30, the problem just disappeared. So it was, and it stopped. And it looked like, is it resolved? Probably no. We don't know the root cause. We don't know may it return back or no or not. So the team continued to work until they get like some compelling hypothesis about this thing. And during the whole process, by the way, it took 9 hours. 9 hours since the moment when the incident was opened, and they realized that what's going on, that this is affecting the catalog, till the moment when they actually closed investigation, and like it was late night at that moment. So the trace analysis showed that there was increased activity on the CMS API at the same time as the incident. So it started about the same time when the incident started, and it ended at the same time when the incident ended. So, like, ring the bell. The RPS for the service was rather low, like few dozen of RPS, and usually catalog serves like 10K, 20K RPS. So this is like not something outstanding. This is normal, like peak of the day, like happens every day. And like just 10 RPS or 20 RPS or even 100 RPS is not much. But the queries coming from there, they were very expensive. They used faceting over high cardinality attribute, and it made the Elasticsearch to spend a lot of CPU and a lot of memory to do the calculation. And next morning at 10:30, everything like repeated. There was the incoming request from the CMS API, and also the increased load on the catalog. But at that time, the team was prepared. They immediately shed the traffic, blocked requests from this API, and it helps to resolve this incident. When the incident is resolved, the next step is a postmortem. So what postmortem is? It's a document and a process to build this document that helps to investigate the past incident, to understand its root cause or causes, if there are more than one, and define some actions to prevent this incident from being repeated again. So we have an incident process that includes, like, in details describes how to build the postmortem document, what actions need to be defined, when the actions, like there are immediate actions and follow-up actions, and immediate actions have the very strict deadline. I mean, like for large-scale incident, it usually a couple of days after the incident resolved, the immediate action should be addressed, because otherwise it may mean that the incident will be repeated really soon. So we kind of work it on this system. We're working on this document, and during the investigation, there was really interesting findings that led us very far from the catalog itself. So first question, why does CMS API need to query catalog API at all? This is the catalog and this is the CMS. CMS is not for product, it's not for ordering. It's not for catalog even. This is a tool to create some content, like some campaigns that appears in the fashion store, some collections, some outfits, different type of content. The reason is that the CMS needs to put some products into the content. And when putting this product, the content creator needs to know that the product are active, they are in stock, they are kind of not like sold out, and they can be used for this. And also they need to navigate through the assortment that in Zalando there's near 2 million of products. And if you want just kind of to search by name, it doesn't work. You need like rich search by many criteria to be able to find things you actually want to put into the content, like to sales campaign, to some topical campaign, and so on. So even though it may be preferable if the CMS will use some other data source, in fact, they often use just the catalog API to get this information. So what may be wrong with it? The normal load coming from the CMS is usually few RPS. When like multiple content creator works on the creating content, there may be, I don't know, 10 RPS. Nothing for catalog. So the next finding was really interesting. Obviously, that was not some content creator who tried to hack the CMS or using CMS API or anything else. It was just a security scanner that went to the CMS API and sent some request. So the next question, why it happened? It happened because the security scanner found that the CMS API become unprotected. So it didn't validate, it didn't check the authentication that we have for everything, and it's just open. So anyone potentially could reach this API and send requests there. And the logic behind the scanner is not just to find that there is a endpoint that is open, but also try to make some queries, and like it quickly found that this is a GraphQL endpoint, so it fetched the schema and started exploring this, sending some queries to the schema. And obviously, one of these queries were searching the catalog. So, like, to explain how we get into this situation, I need to tell a little bit about some internals of Zalando. So, first of all, we have Skipper. Skipper is, you can think about it like about Nginx. That's like our version of Nginx. It's not Nginx at all. It has its own nice features, and it's used for everything. It used it as an implementation of Kubernetes ingress. It used like an entry point for the fashion store and for many other things. It supports OAuth token validation, so you don't need to put it in your application. Well, every application is accessed through the ingress, so we can configure the authentication, auth validation directly inside the ingress by putting like an annotation there or some instructions there. And it's really handy because you can clean up your logic in your app from dealing with the token info, with parsing the parameters, and you can just delegate that to the proxy or like to the infrastructure. And as the Kubernetes ingress syntax, it doesn't contain anything to define this like validation rules or like some special filters. We decided at some point to create an additional object. This is custom resource definition in Kubernetes. Name it road group. Everything is open source, so if you're interested, just go to GitHub, Zalando public GitHub. It has all this thing with implementation, and you can also read documentation about that if you're curious. So why the road group is in some case better than ingress? It has a syntax, I mean the YAML syntax, allowing to put the filters and the rules, or like rows, in a more kind of natural format that easy to read, easy to write, and easy to proofread. And of course, route group somehow tied to Skipper, and many of its things are like created specially to support features provided by Skipper. This is almost real example of the route that was created and what was actually updated in a pull request recently before the incident. And my question, can you spot a mistake? Obviously, the names are like, they're not real names, not real IDs. I just put some names here. Yes, exactly. So the way how the filter token info is implemented, that it verifies that at least one key value from the list appears inside the token. And it goes in a way that it takes a list, and the number of elements in the list should be even. And the first element is the key, the second is value, the next is a key, and next is value. So it looks like you eat Alejandro, you eat Antti, and so on. So it maybe not the best design, and especially as it's used mostly for SELs, and that they're also like in many cases they're just UID appearance here, but it could be other attributes from the token. So, and it may be like a way to generalize, to make it possible to use this filter to check also other parameters in the token. But it also means that very easy to make a mistake like this and just forget to put the UID. Okay, so mistake. It could be all we people, all we make mistakes. So why did the mistake pass undetected? The first kind of guardrail is the Kubernetes API. Kubernetes API was fine. I mean, it looks like a valid YAML. It contains all the attributes that should be there, like no complaints. Kubernetes API say, yes, that's fine. Then we have admission controller for the root group. That's one that knows about the structure of it. And it does a better validation, so it checks that the filters, like auth token, any KV, or forward token, they are real IDs, real names of some filters. And the syntax is correct. I mean that's not just string. This is like a function calls, and the filter should accept some arguments, and the arguments are in quotes, and like this, the commas and closing parentheses there. Everything is placed. So the admission controller check it and say, okay, that's fine. So it ended up with the problem when it being appeared in the runtime, when Skipper actually start to install this filter. So the Skipper translate the the route group definition into the route inside its own route table. So what it did, it didn't ignore just one line. For obviously, if it just ignores one route, it makes the whole thing inconsistent. So it ignores the whole route. What happens next? So we have a service. We have, well, it's route group, but we can think about it as an ingress. And the ingress is not applied, kind of. I mean, the route is not applied. It means like we should not have the route at all, so nothing should work for the CMS API. It should be just unavailable. But there was an ingress. When I said about this OAuth, I said that, well, maybe it was on the slide, I didn't pronounce it, but previously, the OAuth validation was inside the application themselves. So, like, before the thing appeared in Skipper, every developer who developed a new API, they put their calling to the token info and validation of the token. So CMS API is, and this CMS is like an old application. It existed long time ago, so it contains this code that was just switched off because it was not needed. But at the time when it was validating it manually, there was an ingress. And this ingress just was not removed. The thing is that the CI/CD solution we use, it can install or update Kubernetes object. It can install and update AWS CloudFormation templates and do many things. But what it can't do, it can't figure out that if something is removed from the repository, it needs to be removed from Kubernetes. It needs to be done manually. And you know, if something needs to be done manually, obviously it happens when it doesn't done. It's not done. And that was exactly what happened at that moment. So the ingress preserved it for several years in the cluster, unattended. It was just there. And but it didn't affect any operation because in Skipper, the more specific route always wins. So if you have a route for only the for the route, matching any path, and a route for specific route, the specific route will be preferred and will be used. That's why the route from the route group worked, and the route from ingress just slept. And that was the moment when it waked up and striked back. Yeah. Sorry, I probably yeah. So, next question. We figured out why the service, the CMS API, appeared to be open and not kind of protected by authentication. So the security scanner reached this service and start exploiting it. But obviously, people who created and ran the security scanner, the security team in Zalando, they don't plan to ruin some service. They don't want to to load it up to the moment when it failed. They did it with very easy pace. I mean, it was just few RPS, maybe 10 RPS at max. So what happened next? The next happened the bug that existed in the CMS API, and it was never explored before because just the users of the API was the CMS itself, and it used it in a polite way. And the scanner just put some random values in the request, and voila. The first thing was the the amplification bug. I observed this um, pattern several times, but the idea is that you have, in GraphQL query, you have an array, like in this case, this is SKUs array, and also you have a size parameter. So that just contains the size of this array. It's not needed, you can get the size right from the array, but I don't know, for some reason people prefer to do it this way. And what happens next, if you use this value as a size instead of actually counting the number of elements in the array, you may come to the problem when the array is just one element, but the size is some number of thousands. And you multiply this, and you get the same parameter again and again, and it results in like amplification by like several thousands of times. Like a single request may be transformed as several thousand of requests to the catalog API. And the second problem was the inefficient query. So for some reason, people who created this query, they use it faceting. Maybe they think that it's cool, or it's good, or it's needed, but in fact it was not used. They just put something they looked syntaxically correct, and it just calculates the facet over the SKU, or like product ID. And because we have a lot of product IDs, the grouping made enormous load on the catalog API. Again, this problem was never noticed, because how many users like query for products at the same time? Maybe one or two. And this thing created like a constant load coming from the security scanner, multiplied by amplification bug, and make it even worse with this inefficient query. So, we come into learnings. So, first of all, the security scan is a sort of the test. It's like load test. And when you run load test in production, and we run load test in production in Zalando, you should have a run book to stop this test, or at least to shed the traffic, to block the traffic if it causes troubles to a service. Of course, it let you to know that it may be the problems, and it means that you need to do something, but it won't develop into an incident. The second thing is like know your customer, know your client. If you support an API that has a lot of different clients, like different services in various departments, and they call you, you need to have a way to identify where the specific traffic coming from. Either the slow logs, either it's like some increased amount of requests, or maybe something else. So you need to know who to blame or who to contact, and say, hey, you're sending a request that makes my service unhealthy. And the third thing, I think that it's really important that if your API is popular and the query syntax is complex, you need really good documentation. Unfortunately, Catalog API at that time didn't have good documentation, and it made people to do mistakes in querying it, and one of this mistake was one of the root causes of this incident. And like the second thing, maybe related to this, do peer review of your API. I believe that the problem with this like GraphQL API of CMS API can be easily found if somebody did the verification of the API specification. Why do you need the size? You have this list. Why do you need to pass the size of the list as in a separate parameter? Are you going to use it at all? And if you're going to use, why you need it? So if you ask this question, then you just realize that size is not needed. And again, the amplification bug won't happen. And 5 is like most for us, for DevOps guys, don't ignore outdated Kubernetes resources. It may be anything. It may be ingress, it may be service, it may be config map or something else. Just like they don't eat your money, because if you run some deployment, if you have some pods that's running all the time, they occupy space. They kind of made you to run more nodes, and in the end, they cost some money. But for like configuration services, they usually, people don't care much about them. But in fact, they may be, may strike you in some unexpected way.